Hello everyone. So today we are going to discuss one of the application of equilibrium constant. Really it is a very important property of equilibrium constant, that is predicting the extent of reaction. You know, when we write any chemical reaction like this particular reaction, the equilibrium constant is product of the concentration of the products divided by product of the concentrations of the reactants. That means equilibrium constant is actually the ratio of the concentrations of the products and reactant at equilibrium. So magnitude of the equilibrium constant, that gives us an idea of the relative amount of reactants and products present at equilibrium. You know, if product is large, Kc is obviously large. If reactant is large at equilibrium, value of Kc is, equilibrium constant is low. And if both are present in significant amount, then value of Kc is intermediate. So we have three cases. So first case is when there is a large value of the equilibrium constant. If value of the equilibrium constant is very large, that means amount of the product is much larger than that of the reactants at equilibrium. So that means forward reaction is favored. Product is more, that means reaction is favored in the forward direction. And large value we take into account more than 10 raised power 3. Any value of Kc more than 10 raised power 3 is taken as large value, and we say that this reaction is favored in the forward direction. For example, we have H2 plus Br2 to 2HBr, H2 plus Cl2 to 2HCl. See the value of Kc, that is far greater than 10 raised power 3 even, 10 power 18, 10 power 31. That means products are much larger than the reactants at equilibrium. Now, if we have an intermediate value of equilibrium constant, that is in between 10 raised power minus 3 to 10 raised power 3, it shows that reactant as well as product both are present in significant amount. Their amount is comparable. For example, we have these two reactions in which, see, the value of equilibrium constant is, first case it is 138 and in the second case it is 57. And one thing you note, that every time I have mentioned the temperature. So yeah, keep in mind that equilibrium constant is constant at constant temperature. If we vary the temperature, value of the equilibrium constant changes. That's why while writing the value of equilibrium constant, we have to mention the temperature, right? Okay. Now, third case is when value of equilibrium constant is low, that is less than 10 raised power minus 3. So obviously this is the case where amount of the reactant is much larger than the amount of the product, or we can say amount of the product is very less, or sometimes it is almost negligible. In this case, backward reaction is favored. So the example is N2 plus O2 to give 2NO. What is the value of Kc? It is 4.8 into 10 raised power minus 21 at 298 Kelvin. That means NO is present in very little amount. In the mixture, major contribution is from N2 and O2. N2 and O2 are in a very large amount, and very small amount of NO is present at equilibrium. So this whole three cases we can generalize in this case, that if value of Kc is, this is the value of Kc, the value of Kc is 10 raised per minus 3 or less than that, that means the value of Kc is taken as very small, and therefore if it is negligible, reaction proceeds hardly, it cannot take place at all, or we can say backward reaction is favored. Okay, if value of Kc is in between 10 raised per minus 3 to 10 raised per 3, that means both reactants and products are present in significant amount at equilibrium. And third is when value of Kc is greater than 10 raised per 3 or it is extremely large, in that case reaction proceeds almost to completion. So while studying equilibrium, we will take into account this part, because these are the reactions where we have to look how much reactant product is formed. If it is very, very small or negligible, that means there is no need to study it. If it is very large, that means reaction is almost to completion. Product is much larger than reactant, there is no need to study. So major portion where we have to apply laws of equilibrium and we have to study the equilibrium if the value of Kc is in between 10 raised per minus 3 to 10 raised per 3. So that's all about today's session, where I have taken into account that how much extent of reaction takes place, that you can know if you know the value of Kc. Thank you so much for watching this video. Do like, subscribe and share my channel. God bless you all. Happy learning. Jai Hind, Jai Bharat.